Imagine having 3 green apples. They all look and taste the same. We can also say that the sizes are the same, but they may not be the same in the inside. So if you cut open an apple, you will see the seeds at the core. So isotopes are something like these 3 green apples. They are all the same in the outside, but in the inside, they are not. So the other one has 1 seed, the second has 2 seeds, and the third has 3 seeds. Let's take a look at the isotopes of carbon. So the green represents the protons, and the orange represents the neutrons. So again, in this scenario, we don't care about the electrons. We're just going to talk about the protons and the neutrons. Carbon-12, or just carbon, has 6 protons and 6 neutrons. Carbon-13 has 6 protons and 7 neutrons. Carbon-14 has 6 protons and 8 neutrons. The number in the name of the isotopes comes from the sum of the protons and the neutrons. So 6 plus 7, we have 13. Hence the name carbon-13. So 6 plus 8 equals 14. So the name will be carbon-14. So as you can see, they all have the same number of protons because they are the same element, carbon. Remember that the number of protons determines the identity of an atom. Isotopes only differ in the number of neutrons. So, what are isotopes? Isotopes are atoms that have the same atomic number but different mass numbers. This is due to the change in the number of neutrons. And how do we name isotopes? Isotopes are written in 2 ways. It can be written using their symbol with the mass number to the upper left and the atomic number to the lower left. So look at the 3517Cl here. Or it can be written using the isotope name dash the mass number. Hence the chlorine 35. So how do we determine the number of neutrons? So the number of neutrons is determined by subtracting the number of protons, or the atomic number, from the mass number. For example, chlorine 35. The mass number 35 minus the atomic number 17 will give us the number of neutrons, which is 18. Isotopes are not really that stable. So the atoms need a certain ratio of neutrons to protons to have a stable nucleus. So having too many or having too few neutrons relative to the protons will result to instability or radioactivity. Then that nucleus will sooner or later break down to a more stable form. It is a process called radioactive decay. So many isotopes have radioactive nuclei. I think one of the most famous is the carbon-14. We know that carbon-14 is used in carbon dating. Okay, so this slide shows the other radioactive isotopes and their applications in research, industry, or medicine.